Morning. Yeah, well, if I wasn't here, so. It's not gonna be fun. It is not gonna be fun.
Okay, so let's begin. This is the morning review, the worksheet that you picked up yesterday in class. So the number one is all power rule, but we'd have to clean a bunch of these terms up to get it ready for power rule. So I'm just going to clean up see. So first thing, just gotta be careful that binomial square that we take the time to FOIL it out, that we don't just distribute. And as I clean up each of the terms, I'm just trying to uh, resolve each of my issues. So if I have a parentheses, I want to make sure I expand it all the way out. If I see radicals in the denominator with radicals as part of a variable, then I want to make sure I resolve it. And then finally, we can't have variables in the denominator. So this thing here, that root 11 is just a number, so I can just have it as a fractional value. I don't want to bring that up. I just want to push it to the side so that it doesn't feel like it's impacting my variable there. And then as I distribute my coefficients, my expression term in front of my parentheses, I'm going to have to multiply the 7x cubed. And as I multiply variables, remember, you're going to be adding exponents. And I'm just rewriting all my terms over so that I can just do power rule all at once for all the terms. Okay. Any questions so far?
So for that, you're literally just like expanding it initially and then you do power rule.
Right. So you want to make sure that all your conditions are met. No parentheses are left in the problem. No radicals that have not been resolved. Radical converted to rational exponents, and then variables all brought into the numerator. If you meet all three conditions, you know you're ready for power rule.
Okay. So, for question two, in the key, there's just like I thought it might be a mistake.
Okay.
It's where or 4x gets transferred to -1.
Yeah, you're right. That should be a minus.
Okay.
And then at the end, it'll turn into a plus, right?
Right.
Yeah.
That's what I was concerned about. Like, well, yeah.
No, you got it. So I'll work through it with the correction.
Oh, so are you gonna do number 5, the one on the board?
Yeah, so I'll do number 5 as well. So
Thank
we'll do 2 and 5.
For -6 over √11 in the answer.
Yeah.
I put -6 over 11 to the power of 1/2. What is get myself to there?
Nope, you're fine. You can leave that. You can do 11 to the 1/2 and be okay. Good. Yeah, good question. E is not a variable, right? It's a number, right? So a number raised to an exponent is still a what? Well, it's still a number. We don't know what that, I mean, it's like 2.7 to the 4th power. That's a number. A number times a number is still a number. So that's a constant, right? What's the derivative of a constant? Zero. So yeah, any numeric value is derivative. If there's no variable there, it'll just drop to be a 0. Okay, any other questions with 1? Right, number 2, the instructions for this problem is use power rule only, no product rule, and no quotient rule. So we're going to spend the time to distribute, and also I'm going to try to rewrite my radical there. I'll distribute that 4x through, and as I do that, I'm also going to start splitting up into individual fractions. So as I multiply the 4x through, remember, if you multiply variables, you're going to end up adding exponents. So there's a hidden 1 here, 1 here as well. So 1 plus 1/2 is same thing as 2 over 2 plus 1 over 2, which is 3 over 2. This becomes 12x squared. Any questions so far? Yeah, my key, I think my key, I just forgot to distribute the negative or the positive and negative, and I made it positive. So my key is showing wrong here. This should be minus. Yeah.
How do you know, like, to do that and not the quiz?
Yeah, so I will specify on the quiz to indicate use power rule only, no product and quotient. Yeah, I'll specify those instructions. Okay, any questions so far at this point? Now we know that we're still not ready for power rule, but we have taken care of the parentheses, so we're making progress. But we can't go through power rule until the variables are merged together. So because these are variables divided by each other, the way we undo it is we subtract exponents. Okay, so if we want to merge variables divided by one another, we're going to subtract exponents. So 3/2 minus 9/2 is -6/2.
We have to shrink that as -3.
Right, I'll do that next, which I'll reduce it. 2 minus 9/2 is same thing as 4 over 2 minus 9 over 2, which is -5 over 2. Oops, minus. And then 1 minus 9 over 2 is same thing as 2 over 2 minus 9 over 2, which is negative 7 over 2. Okay, I'm ready to find my derivative. All of my conditions have been met. No radicals, no parentheses, and no variable in the denominator. So every term is ready for power rule. Go ahead and apply power rule. You can make that -3 if you want before you bring it down, but it doesn't really matter. And then once you bring your exponent down, you're subtracting 1 from the exponent. So -3 minus 1 is -4. Going to do some cleanup here, reduce fractions, because these are fairly manageable, but you don't necessarily have to reduce fraction. I won't take off any points, but I do want to see the negative exponents brought down. So I'm going to reduce that. I can take a 2 from both 24 and 10. So I'll get -12 over 5. And then I'm also going to start bringing those variables down. I'm already at the answer level. I'm just trying to do some cleanup. I already have my derivative here.
There will be some questions on the quiz that you're gonna ask. Well, it's like free for all, right?
Right. Or a problem like number 3, where
Right.
I'm not going to indicate what rule you're going to use, but the only one that you can use is quotient rule.
Yeah, okay.
Yeah. So yeah, it'll be very similar to the setup for your quiz. Okay. Any questions with oops, sorry, this should be no. Okay, any questions with 2? We'll do another similar one to this one, number 5, that I have up on the board. We'll do that at the end once we get through both pages. Okay, no questions? Right, number 3, here's our function x over x squared minus 2, find f prime. So the rule is, the instruction is just to find f prime, and we have to decide what rule to use. This is numerator and denominator, where there's more than one term in the denominator. Both are showing variables. We're kind of forced into quotient rule here. So let's find f prime. And then we can worry about the tangent line equation that comes after. Okay, so this is my f prime. I'm just going to do some cleanup. And again, when you do cleanup with quotient rule, you're not going to touch your denominator. All you can really do is work on your numerator, but whatever your denominator shows, you're largely going to leave it alone. Okay, any questions with cleaning up the derivative? All right, we're going to find our order pair, which we need, and our slope, and then we can put it into a point slope form. So at x equals 1, so I want to find the y value of the function at 1, and I also want to find the slope of the graph at 1. So I'm just plugging into the original function here to get the y value. There's my y value, -1. There's my slope. Any questions with first page? Right, back page is all related to that particle motion problem at the top, stem at the top. So part A, you're just finding your velocity and your acceleration. You're just moving your way down to the second derivative and then plugging in to find your velocity value and your acceleration value. Notice your units here is not feet per second, it's meters per minute. So I want to make that adjustment. All right, what's the formula for average velocity?
You use the original equation,
Mhm.
and then this one would be x
Into
to
the
minus x.
Yeah, so slope, right? So slope using position. Use the function above it. Don't use velocity, don't use acceleration. Okay. All right, these numbers are a little bit large here, but you'll plug 2 into the position function. And then 1 into the position function. Okay. Part E, when is a particle at rest? What's our strategy here? Set, yeah, good. Set velocity equals 0. Factor. Continue factor. Multiplies to be 5, adds it to be negative. All right. Multiplies to be -5, adds it to be -4. Solve for t equals 5, t equals -1. If I set 3 equal to 0, I'm not going to get a real solution, so I can ignore it. So any restrictions with our t values? Okay, what's our restriction? Yeah, has to be greater than equal to 0. Now, we don't want to always assume that your instructions will always tell you what's the domain. Is it all real numbers? Is it just positive numbers? So you're always making your decision based off of what's the criteria. So in this case, we are outside of our range for -1, so we're going to remove it, but we'll keep the 5.
I'm confused on D and where you got your.
Right, so x of 2,
X.
x, yeah, it's not v, I know. It's tempting because you see that word velocity and you want to.
Okay.
So just be aware of why this is an easily missed problem if we're not careful. Okay, good. Any other questions? A through E. All right, find the average acceleration of the particle from 1 to 3. So very similar to wording here. We got to be careful again. What's our formula for average acceleration?
Change in velocity over
Good. Change of velocity over the time. We don't use acceleration. We use the function above it. We use velocity. Remember, acceleration is the rate of change of velocity. So that's why our units look a little different. It's meters per minute. And so when you clean that up, it ends up being meters per minute squared. When is the particle moving right? When the particle change directions? So let's create our sign line, our velocity sign line. We have our data that we need from part E. We know when the particle is at rest, so that's going to help fill out our sign line. Let's also find particle moving left as well, just so we can have everything in front of us. I'll test 1, I'll test 6. But again, you can choose any number to test as long as they're inside the interval. I'd like to use numbers as small as possible without a calculator. They all go into your velocity function. Plug 1 in, 1 minus 5 is negative, 1 plus 1 is positive, negative times positive is negative. So you know moving left in this first interval. Plug 6 in, positive, positive. Once you get the signs to show up, we don't care about these numbers anymore. Cross them out so they don't distract you. Okay, so moving left, moving right, we're going to ask for both of these. So moving left, what would you say?
The 0 bracket.
Good. 0 to 5, bracket around the 0. And the reason why is because we want to test 0. 0 is not a moment when the particle is at rest, so it may already be moving. If I plug 0 into my velocity function, I'll get 0 minus 5, 0 plus 1. This is negative. So 0 is already moving, and 0 is part of my domain. I do want to include 0 as part of my domain. And since 0 is already moving left, we're going to have to include that in our statement. Our reasoning is simply because velocity is less than 0. Moving right from when to when, 5 to infinity, parentheses for both. And then when does particle change direction? Yeah.
It's an interval would not be brackets.
Right. There's no bracket here because at 5, it's not moving. So we don't want to include that as part of moving left or right. It's at a stopping point. Particle change direction at t equals 5. And the reasoning is because velocity changes signs. Part H, any questions so far? Up to part G. Part H, what is the displacement of the particle from 1 to 4? So displacement it's basically just the numerator of your average velocity. It is just your change in position, and that's it. Okay, there's no time component. It's just change in position. So it's just x of 4 minus x of 1. And if you get a negative number, keep it. Right? You're not going to make any changes. It's okay to get a negative number if that's what happens. So again, sorry for these large numbers. You're going to get easier numbers to use to be able to do without a calculator. I'm just going to, if I plug 1 into the position, I'll get negative 19. If I plug 4 into the position function, I'll get negative 91. Careful with your negatives. Keep track of them. And displacement is like distance. It's a distance value. So it is just meters. It's just inches. There's no rate. Okay. You're just measuring distance between where you are at the beginning and where you are at the end. total distance is going to be similar in the sense that we are still needing the locations at these endpoints. So we need x sub 3, we need x sub 6, and we need a place, if there's any locations where the particle changes direction. Is there any moment when it changes direction? At 5, right? And the velocity sign line tells us that. If there's no change in direction, then we don't need another location. All we need is the starting point, ending point, and then a point where there's a change in direction. And now I'm just going to find the locations of each of these moments in time for this object. And again, sorry, these numbers are not easy to plug in without a calculator, and it'll be easier. So if I plug 3 into the position, I'll get negative 71. If I plug 5 into the position, I'll get negative 99. If I plug 6 into the calculator or into the position function, I get negative 89. So what this is saying is you're starting at negative 71 on the x-axis, and then you're walking over to negative 99 while counting your steps. And then from negative 99, you're walking back to location negative 89 while you're counting your steps again. And then all the time, you're just keeping a positive counter. You don't care which direction you're moving. Every step you take, you're just going to continue to add up that number. So I think the easiest way to go about it is just imagine you're actually walking on the number line. So imagine you're starting at negative 71, you're walking all the way over to negative 99, and then you're walking back to negative 89. So from negative 71 to negative 99, how many steps would you have taken? 28. And then from negative 99 to negative 89, how many steps would you have taken? 10. And then you've taken 28 steps to the left, you've taken 10 steps to the right. How many steps have you taken in total? 38. That is your distance.
Maybe positive, right?
Oh, yeah, good. Yeah, always positive for distance. It's okay to have your displacement being negative, but your distance is always positive. Okay, what's our strategy for determining increasing or decreasing speed? Good. Compare signs of velocity acceleration.
Would it be feet or would it
Yeah.
be meters?
Oh, sorry, you're right. I did not make that adjustment in my key. Should be meters. Good. So we have to compare signs between velocity and acceleration. If both velocity and acceleration show the same signs, then speed is speed is increasing. But if one is positive and the other is negative, then speed is decreasing. Right. Now for part K, is velocity increasing or decreasing? So wording is similar, but you see the word velocity increase, decrease. This time we're looking at just what? Not velocity, acceleration. Okay, let me say it this way here. Is velocity increasing or decreasing? This is basically saying, is velocity a positive or negative slope? And if you want to think about it that way, is velocity positive or negative slope, then you got to look at the slope information, right? Your acceleration is giving you slope information about velocity. So if your acceleration is positive, then velocity is showing a positive slope. If acceleration is negative, then velocity is showing a negative slope. So this is asking about the slope of velocity. It's not asking about whether velocity is positive or negative. It just wants to know, is the slope looking like this, or is it going down? So that's why we're just looking at acceleration for part K. So velocity is negative at 1, and acceleration is also negative at 1. They're both showing negative, so at t equals 1, speed is increasing, since velocity and acceleration have the same signs. Here is velocity increasing or decreasing, basically asking about the slope of velocity. We know acceleration is describing the slope of velocity. Acceleration is positive, so there's a positive slope of 6 on that velocity graph. And so velocity is increasing since my acceleration is greater than 0.
We have a question that says acceleration increasing or decreasing?
If it did, then you will have to find the derivative of acceleration, which I won't ask you. Okay, sorry, any other questions? I have another power rule problem for us to practice with. If you can just find another sheet of paper and copy that down on the board. Take the time to expand your numerator. Careful, if you're distributing your variables, you got to add exponents, and you don't have common denominators. You got to create common denominators. So 1/2 plus 4 is the same thing as 1/2 plus 8/2, which is 9/2. 1/2 plus 4/2 is 5/2. And there's no variable here, so I keep that x to the 1. And as I do that, I'm also beginning to separate each of the fractions so I can individualize each problem, knowing that this is going to end up being 3 power rule terms. They're all going to be independent of each other, but there's still something standing in the way. My denominator variable needs to be brought up. And the way we bring it up is we subtract the exponents so we can merge the x's together. So 9/2 minus 3/2 is 6/2, which is the same thing as 3. 5/2 minus 3/2 is 2/2, which is the same thing as 1. And then 1/2 minus 3/2 is the same thing as -2/2, which is -1. And I'm just doing a little bit of cleanup. And then that way my power rule feels even easier because there's no exponent, fractional exponents in the way. It's just, they're all ending up being a pretty manageable power rule terms there. So now we can do power rule. Everything up to this point is just cleanup. We're just doing algebraic steps to get all the way up to our starting line. We know we're ready to go because no radical variable, no variable in the denominator, and no parentheses, right? All 3 are taken care of. Every term is ready for power rule. Now we can do f prime. Bring down the exponent, subtract 1 from the exponent. And then after you get your f prime, look at your variable. If you still have a negative exponent, then you want to bring that variable down. Otherwise, you can keep your expression.
The quiz should be front and back.
Let's run it back, yeah. I don't think the quiz will take the whole period, so at the beginning of class, I'll give you guys 5 minutes to look over your notes. And then I'll ask you to bring your books up to the front and throw it up on the wall, and then we'll take the
They
quiz.
said they're a little simpler, like equations than the one.
Yeah, yeah, yeah.
They're kind of, it's gonna be kind of similar. That's what we.
Yes, yeah. Front page, you got power rule, quotient rule, tangent line equation, the back page is all Markov motion.
Is there any way, is there any way you can write on the board like an outline of the quiz? We can like think about it. Like just like basic rules on what it's gonna be on the quiz.
I think it's literally gonna be this, just different numbers.
This was 2 power rules, right? Was these were both power rules, and then we did quotient rule in our tangent line equation?
You're right. These are 2 power rules. This is power rule where that's the only way to do it. This is power rule where you could do quotient rules, but I'm forcing you into power.
Okay. So,
Yeah, I'm gonna say these approaches. I'm gonna say use power rule, no quotient, no problem.
and then this one was.
You have to use quotient. There's no other
Fall
way.
asleep, just like.
And then like,
Thank you, Mr. Yang.
formatted like this. Thank you so much. Okay, I wouldn't consider myself that.
Yeah.
Like you might, my best class.
Then it's.